So, in continuation to the previous video of parametric test, which was all about, I'm sorry, statistical test, which was all about parametric and non-parametric test, where I gave you kind of overview on what parametric test is and what non-parametric test is. And so, uh, in today's session, let's try to give a thought on what t-test is. Let's try to understand what is a t-test, when do we use t-test, what are different types of t-tests that we use, and in next video, we will see the implementation, the Python implementation of t-tests and all the three types of t-tests. So to start on with, uh, uh, as you know, parametric test is a statistical test which uh, makes specific assumptions about the parameters uh, of the population distribution from which the sample data is drawn. And when do we use parametric tests? So there are few assumptions. For example, data should be normal. Secondly, there should be homogeneity of variance, and uh, the variance should be same all over the uh, data distribution. So this is all about when to use parametric test. Now let's see t-test. So there are three types of t-test. First, let's see what t-test is. T-test basically is when you compare the mean of two groups or compare a mean of a particular group to a known value. So t-test is basically comparing mean values of two groups. Either what you do is uh, compare the mean values of two groups, or what you do is compare the mean value of group with some other value. This is what t-test is. So in simple terms, when you try to compare the mean values of two groups, that is what t-test is. Now let's see three types of t-test. One sample t-test, independent two sample t-test, and paired sample t-test. In one sample t-test, there is only one group involved. In these two, there are two groups involved. Uh, as in paired sample t-test, there is only one group involved, but two separate instances of that group. So I'll try to tell you what the difference is between all the three. Let's see first one sample t-test. Uh, One sample t-test, when do we use it? When you want to compare the mean of single group to a known value. Now, to give you an example of this, let's say there is a class of students, and you want to compare the mean value of this group, this class of students, to a specific value, and that specific value can be, so let's say you want to compare the average height of this class, and you will compare the average height of this class with a known value, which is, let's say, in our case, we want to compare this mean value of the class, age of the class with, or height of the class with, uh, uh, the nation's mean value of its height. So comparing India's mean height with the mean value of the class is what one sample t-test is. So what we are trying to do is in one sample t-test, this is my class of student, and I calculate mean height, and I know this value, which is basically my nation's mean value of its height. So I'll compare these two. The formula is x bar, which is the mean value of class, minus mu, which is uh, this value, the country's mean height, and standard deviation of this group divided by root n. Root n is basically number of samples or number of students in this group. Moving on, independent two sample t-test. Independent two sample t-test. When do we use it? When we compare the mean of two unrelated groups. To give you an example, let's say in this class, I'm comparing mean height of boys with mean height of girls. So the comparison of mean height of boys versus mean height of girl is called as independent two sample t-test. This is an example of independent two sample t-test. You have two independent groups, which are the boy group and the girl group, and you compare the mean height of their ages or heights. Formula x1 bar, which is mean of first group minus mean of second group, and under root s square of the standard deviation square of the first group upon uh, total number of boys in that group plus standard deviation square of second group, which is girls group, divided by total number of girls and taking the root of it. Third is paired sample t-test. Third is paired sample t-test. When to use when we compare the mean of the same group at two different times. Now, to give you an example, uh, 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 let's say comparing, so let's say we have these patients and we compare weight of the patient before their treatment, and again same patient, I'll compare weight of them, weight of their uh, like weight of these patient after the treatment. So I have same number of patients, same number of groups, same number of peoples, but comparing their mean before an incident and after an incident is a popular use case of paired sample t-test. So when do we use it? When we compare mean of the same group at two different times. At two different times. Now, uh, to understand the formula, D is basically differences. So mean of difference of mean. So let's say uh, first difference, second difference, third difference, fourth difference, fifth difference, sixth difference, seventh. So I'll subtract x1 minus y y1, x2 minus y2. Let's say this is x and this is y. So x1 minus y1, x2 minus y2, x3 minus y3, and I'll get uh, uh, new array having, let's say, subtraction 1, subtraction 2, subtraction 3, so on and so forth. And now what I'll do is I'll take the mean of this. I'll take a mean of this. I'll take the mean. Okay. So I'll subtract the differences. I'll take the differences of each pair before and after, and I'll create an array. Now I'll take the mean of this array. After that, I'll take a standard deviation of this, which is my SD. This is my SD, which is also my D bar, and total number of pairs in this is my N. Okay. Now, to understand this, basically in t-test, what do we do is difference. This is a generic formula, difference in mean or so let's say difference in mean divided by uh, standard deviation upon under root of total number of population. Total number of population. So difference in mean in every three test, what we are doing is we are kind of taking, if you see this, difference of mean, difference of mean, difference of mean, and then dividing by standard deviation root n, standard deviation square in root, and root n, standard deviation and root n. So moreover, this is the formula. That's it for this video. In next video, let's see the Python implementation of this. Uh, Thank you.